You didn't choose your phone. Not really. You chose a brand, a color, a size, but the chip inside, that impossibly thin slice of silicon running 16 billion transistors smaller than a virus, that choice was made for you. Made possible by one machine, in one factory, in one medium-sized Dutch city that most people alive today have never heard of. The company is called ASML, and if you ask the average person on the street to name it, they couldn't. But ask the CEO of Apple, ask Nvidia, ask the President of the United States, the Premier of China, or the President of South Korea, and every single one of them knows exactly what ASML is. Because they have to. Because without ASML, none of them can build the future they're racing toward. Here's what the map of modern technology actually looks like. Nvidia designs AI chips. Apple designs the A-series silicon. Samsung, SK Hynix, Micron make memory. And everyone ships their designs to TSMC in Taiwan to be manufactured. TSMC is the node everyone talks about, the world's most important factory. But here's what they never tell you. TSMC is only possible because of ASML. To print a cutting-edge chip, and we mean print, literally projecting light patterns onto silicon, you need a machine that can etch features smaller than 10 nanometers. A human hair is 80,000 nanometers wide. These transistors are so small, standard light can't even see them. You need a different kind of light. Extreme ultraviolet light, light with a wavelength of just 13.5 nanometers, generated by firing a laser at a tin droplet 50,000 times per second inside a near-perfect vacuum. Only one company in the world has ever built a machine that does this. ASML. They hold 100% of the global EUV market. Not 70%, not 90, 100, zero competitors, zero alternatives, zero substitutes. Remove them from the equation, and the $5 trillion global technology economy doesn't slow down. It stops. Every AI server farm goes dark. Every smartphone fab halts. Every autonomous vehicle program stalls. Every defense satellite program freezes. The entire digital infrastructure of modern civilization, traced back to its root, leads to a quiet industrial complex on the outskirts of Veldhoven, Netherlands. This is the story of how one company came to hold this kind of power, and the secret war now raging between superpowers over who gets to keep it. To understand ASML's power, you need to understand what their machines actually do, because once you do, it becomes completely rational that no one else has managed to build one. Inside every modern processor is a lattice of transistors, logic gates so small that billions of them fit on a chip the size of your thumbnail. To etch those transistors into silicon, you need to project an image of the circuit pattern onto the wafer, the same way a projector displays a film onto a screen. But at a scale so extreme, standard visible light simply cannot do it. Light has a wavelength, and you cannot print features smaller than the wavelength of the light you're using. So ASML had to invent a new kind of light. Extreme ultraviolet, EUV, with a wavelength of just 13.5 nanometers. Generating it requires firing a high-powered laser at a droplet of liquid tin, no bigger than a single human cell, 50,000 times per second. The droplet vaporizes into plasma. The plasma emits EUV light. That light is then captured, reflected off 6 custom mirrors, each one polished to atomic level smoothness, and directed through a complex optical system before it finally touches a silicon wafer. Those mirrors are made by Carl Zeiss in Germany. ASML holds a 24.9% stake in Zeiss. That's not a supplier relationship, that's a strategic lock-in. There is no other manufacturer in the world capable of producing them to that standard. The light source itself, the laser that fires at the tin droplets, is made by Cymer, a San Diego company that ASML acquired outright in 2013. The laser systems are made by Trumpf, another German precision engineering firm. ASML doesn't just dominate the machine market, it has systematically acquired or partnered with every critical link in its own supply chain. It is vertically integrated into its own monopoly. Now, let's talk about money. The standard ASML EUV machine, the Lona model, costs approximately $180 million per unit. That is the price of a Boeing 737, for a single machine that does one job, and TSMC, Samsung, and Intel all buy them by the dozen. It costs between €380 million and €400 million per unit. Each one requires 3 customized cargo aircraft just to transport. Roughly 250 engineers spend months on site just to install it. It stands 4 stories tall and generates its own internal near-vacuum environment, because EUV light is absorbed by almost everything, including air. And here's the key thing. ASML spent over €4 billion on R&D in a single year just to stay at this frontier. In 2019, something quiet happened that would reshape global power. The United States government placed a call to the Dutch government. The message, simplified: ASML cannot ship its most advanced machines to China. The Dutch complied. ASML's export license for EUV machines to Chinese customers was revoked, quietly, without fanfare, without a press conference. Here's why it mattered so much. By 2021, China was purchasing roughly 33% of ASML's total revenue. Chinese chipmakers, SMIC, Huahong, and others, were desperate to close the gap with TSMC and Samsung. EUV machines were the only path forward. Block them from EUV, and you freeze their chip industry at an earlier generation. The restrictions have since expanded, escalating through 2022, 2023, 2024, and into 2026. China has now committed upwards of $143 billion in state funds to build a domestic semiconductor industry from scratch, through entities like the National Integrated Circuit Industry Investment Fund, through forced technology transfer agreements, and through aggressive recruitment of semiconductor engineers from Taiwan, South Korea, and the United States. The result, so far? SMIC, China's national champion chipmaker, has managed to produce a 7-nanometer equivalent chip using an older DUV technique called multi-patterning. It requires running a wafer through the lithography machine multiple times to achieve what EUV does in a single pass. It works, technically, but it is 4 times slower, 3 times more expensive, and yields are far lower. You cannot run an AI arms race on that process. China has no EUV machine. It has no known path to building one. Carl Zeiss won't sell the mirrors. Trump won't sell the lasers. Cymer, now ASML's subsidiary, is off the table. The entire supply chain is locked behind export controls. Even if China reverse-engineered every individual component tomorrow, assembling them into a functioning system requires a knowledge base that took ASML 30 years and billions of euros to accumulate. Without EUV, China can manufacture chips. But it cannot manufacture leadership. It cannot manufacture the 2-nanometer process that TSMC is already shipping. It cannot manufacture the sub-angstrom transistors that high-NA EUV will enable. It is fighting the chip war with the previous generation's weapons. And here's the business paradox that makes ASML almost uniquely bulletproof. Losing China has barely dented them. The monopoly doesn't just survive the geopolitical storm. It profits from it. By 2026, a quiet civil war has broken out inside the semiconductor industry, and the weapon at the center of it is the most expensive single piece of commercial hardware ever built. The high-NA EUV machine. 400 million euros, 1 unit. Here is the conflict. TSMC, the world's most powerful chipmaker, the company that manufactures chips for Apple, Nvidia, AMD, Qualcomm, and half the world's technology, has looked at this machine and said, not yet. Their internal roadmap doesn't schedule high-volume high-NA production until approximately 2029. Intel has made the opposite bet. Intel, fighting one of the most dramatic corporate turnaround battles in tech history, has chosen to be the first foundry to deploy high-NA EUV at production scale. Their Intel 18A process node is built around it. Multiple high-NA EUV machines, each costing north of 380 million euros, have already been shipped to Intel facilities. The logic is clear. If Intel can master high-NA EUV before TSMC does, they can leapfrog the current generation. Meanwhile, Samsung is carving out a third path. Rather than competing with TSMC head-on for logic chips, the processors and AI accelerators, Samsung is targeting the memory layer. This is the matrix. Every player is running a different strategy. Every strategy runs through ASML. Now let's zoom out to the number that matters most. ASML's projected 2026 revenue, between 36 billion euros and 40 billion euros. Their market capitalization, above $580 billion. That makes ASML more valuable than the entire gross domestic product of Belgium. A company that most people have never heard of is worth more, by market cap, than the entire annual economic output of a Western European nation. And they did it by building one thing nobody else has managed to build, and then making the entire world depend on it. This is the structural nature of their monopoly. Which brings us back to you. Every AI response you receive, Every video you stream, every satellite image that gets processed, every autonomous vehicle decision, every medical imaging scan, every financial transaction, every message sent, runs on a chip. Every chip at the leading edge of what's possible was printed by a machine made in Veldhoven. There is no backup. There is no plan B. There is only ASML.